Okay, so today we're having a look at percentage by mass of an element in a compound. So let's take our first example. First example is magnesium bromide. And our question is going to be, what is the percentage of the mass of magnesium bromide that is due to magnesium? So let's draw this out slightly differently. We know that magnesium bromide contains a ratio of one magnesium ion to two bromide ions. Okay, but we also know that these have different masses. So if we were to look on the periodic table, we would see that magnesium has a mass of 24. So a magnesium ion has a mass of 24, and each bromide ion has a mass of 80. So the just looking at it, by far the greater proportion of the mass is going to be due to these much heavier bromide ions than is due to magnesium. So the first thing we're going to do is work out what the relative relative formula mass, the MR, is of magnesium bromide, which we've done before. We know that the MR of this is made up of one magnesium and two bromide ions. Magnesium ion has a mass of 24. That's the value, the relative atomic mass I find from the periodic table. And the bromide ions each have a mass of 80. Again, that's the mass I find from the periodic table, which means the total mass, the total relative formula mass of magnesium bromide is 184. So my question is, what is the percentage by mass of magnesium in magnesium bromide? So step one, which we did, was to calculate the relative formula mass. So I need to know that I'm trying to find the percentage of magnesium. There's one magnesium ion per formula unit. So 1 times magnesium divided by the MR that we calculated, which is 1 times magnesium and 2 times bromide ions. So the magnesium ion has a mass of 24, and 1 magnesium and 2 bromides we've already worked out comes to an MR of 184. That gives us a value of 0.13. And we know that if we want to convert that into a percentage, we multiply that by 100, and that gives us 13%. So the value of the percentage by mass of magnesium in magnesium bromide is 13%. So just a quick review about what we did. The key thing here is this idea here. We know the formula, and we're trying to find what magnesium is out of all of this. We found the values for the mass of magnesium and the mass of bromide ions from the periodic table. So let's have a look at a second example, a slightly more complicated example. And we're going to work out the percentage by mass of aluminium, so Al, in aluminium oxide, which has the formula Al2O3. So let's just think about that diagrammatically again. We don't have to do it this way all the time, but it just helps us to get a handle on what we're thinking about. So aluminium oxide has got 2 aluminium ions in it, and aluminium ions have a mass of 27. Again, we would use the periodic table to find those. And then we've got 3 oxygens, each of which, or oxide ions I should say, each of which have a mass of 16. Again, that number there I find from the periodic table or a data sheet which has those. So we're trying to find the percentage of aluminium in this. So this time there are 2 aluminiums in the formula. So it's going to be 2 times our mass of aluminium divided by 2 times aluminiums and 3 times oxide ions. So that gives us 2 times 27 divided by 2 times 27 plus 3 times 16. That will convert to 54 divided by 102, which gives us 0.53. We want to find this as express this as a percentage, so we multiply that by 100, and that gives us an answer of 53%. So what's the point in doing this? Well, the purpose of it is it allows us to work out the maximum mass of an element that can be extracted from a compound. So my question that I'm going to ask is to calculate the maximum mass of iron, so iron, Fe, that can be extracted from 200 tons of iron ore. And iron ore, we're going to say, has the formula Fe2O3. So step one is for us to do what we did previously. We want to work out the percentage of iron in iron ore. So step one, the percentage of Fe in Fe2O3. I say percentage, actually we're going to leave this as a decimal, but so I suppose effectively it's the ratio. So we've got 2 irons divided by 2 irons and 3 oxygens. Iron has a mass on the periodic table of 56. So 2 times 56 divided by 2 times 56 plus 3 times 16. That will give us 112 divided by 160, which as a decimal gives us 0.70. I'm not going to convert this into a percentage because I'd end up just reversing that in the next step. So step 2 is going to be to multiply my decimal, my ratio, so 0.70 multiplied by the mass, which is 200. So the maximum mass of iron that we can extract from 200 tons of iron oxide is 140 tons. Thank you very much.